I'll say a little of what I know they are or think they are. So there are forms of reusable code that you can use to solve recurring programming problems. So there are certain kinds of problems that occur every time as when you're coding, and these patterns can help you map out how to think logically through them.
Okay, exactly. So design patterns are what general and reusable solutions to a common problem we face each and every day out. The term design patterns in programming was actually gotten from an architect, Alexander, who said patterns describe a problem which occurs around us, and then what describe the core solution to that problem. And then you can use that solution a million times. Anywhere you need that problem, use this pattern. So if I should ask you, we have 20 oranges and there are 5 people, and you need to share that oranges among those 5 people. How will you get each person? How many oranges will one person get? Anyone? There are 20 oranges and there are 5 people. You need to share those oranges among those 5 people. How many oranges will one person get? 4. So how did you get 4? Okay. So you knew out of the arithmetic operations you needed to divide, right? You needed to divide. Out of multiplication, subtraction, you knew that the best solution to solve that problem is division. And that's what design patterns equips you with. It equips you with the various tools to problems, and when you meet them, you know that yes, this is what I need to do to solve that problem. And so what are the elements of design patterns? First of all, a design pattern should have a name that describes the problem, the solution, and some of the consequences, the trade-offs for using that pattern. Moreover, it will be a pattern if it doesn't describe the problem it is solving. And then goes on to show the solution that it is bringing about, and then the consequences. These consequences are the trade-offs that you encounter when you use certain design patterns. Certain patterns can get complicated, that it might affect your code one way or the other, but you get through that and you see how to resolve that. Okay, so why are they important? As a programmer, you need to equip yourself with this design pattern so that, first of all, they provide proven solutions to software problems that you face. The problem that you face now when you're coding has already been faced by somebody in the past, and that person came up with a pattern or a solution to that problem. So you just go in there, use that solution, and you use to solve the problem. You don't need to crack your head about how to go about it. Just like the division problem. Someone came with that division and said that if you face this problem, you have 20 oranges and you need to share it among 5 people. Use the division so that everyone gets 4 and then you're all. And then they make communications between developers more efficient, right? If you're in a team of developers, right, and I am programming, and I face a particular problem, and I come to you, my team member, as a casual programmer, and I describe the problem to you, because we all know what design patterns are. You can give me a pattern, a solution to go and use without you going into the details of create this interface, let this class implement it, and all that. When I just tell you, okay, use a singleton pattern, you know what that means, and then you go back, and you can tell me, oh, the singleton pattern wouldn't be effective. Let's use the proxy pattern and stuff like that. That way, developers can communicate with each other without going into the details. And moreover, they make it easier to change and maintain code. Most often than not, we find ourselves as developers trying to get the application to work. So we hack our way through, make sure that it is working, and then we leave it at that. If they ask us, it is working. So we are working. And then when later on, a small change comes around, and then you're like, hey, you have to go back to rewrite your code and stuff like that. So design patterns helps you to make sure that your code can accommodate change. Whatever change, you can easily plug the change in so that without changing extensively the application code. And moreover, they prevent you from wasting your time into hacking to solutions, which I said earlier on, trying to just make sure that the application works. So design patterns talks about code craftsmanship. You design the code, write stylish code to distinguish yourself from the pro and the beginner. Right? So design patterns use some basic overall concepts and principles. So I'll take you through them. So as developers, these are the basic object-oriented basics that you need to do. Abstraction, encapsulation, polymorphism, and inheritance. Abstraction means defining things on a higher level without giving concrete implementation to them so that the subclasses will find their way to it. Same with the encapsulation, hiding details of object oriented from the outside world, so that you hide the environment or the variables in objects or classes. Same with polymorphisms, and then inheritance, where you have a subclass and classes extend from those classes. And then some object-oriented design principles. Design patterns helps you to think through your application before you code, right? So when in the process of thinking through your application, you're able to separate what varies, what is likely to change over time. You're able to identify the things that are able to change over time, and then you separate them from the things that are always going to be constant that you work with. And then you should always favor composition over inheritance. Instead of having a subclass that has all the attributes and the methods that all the subclasses will inherit from, you should look for the ones that vary and then make sure that the subclasses have those ones, are part of them, but not inheriting from a superclass, so that when it can make it easy for changes to take place in the application. And then you should always strive for loosely coupled design between objects. This meaning that objects are created, and objects in one way or the other, they are communicate with each other, right? If you design your application so that a change in one object affects the way the other objects work, then you are in for a chaos, because anytime you change one thing at one place, you have to go in and change where that object is communicating with that object. So you make sure that they are loosely coupled, so that one object can be changed without affecting the other object, and your application can still run. Okay, so there are what are the basic classifications of design patterns. Design patterns are classified under three major categories, right? We have the creational design patterns, the behavioral design patterns, and then the structural design patterns. So I'll touch on each one of them. So creational design patterns are patterns that deal with how objects are created in your application. You don't just open classes and you initiate them and then we are off and we are doing this pattern makes sure that the way objects are created in your application follow a certain format, a certain pattern. So these are the various creational patterns that you can look through. We have the factory method pattern, the abstract factory, the builder pattern, the prototype pattern, and then the singleton pattern. Right? But among these, I will only touch on the factory pattern, so that this is just to give us an insight on what design patterns are, so that we can go back later and dig deeper into how to make our code better and maintainable. Okay. So the factory method pattern, it defines an interface for creating objects, but let the subclasses to decide which class to instantiate the object. Let me show you a UML representation of a factory method pattern. I forgot to mention that design patterns also make heavy use of UML diagrams, right? If you know of a certain design pattern and you don't know how the UML representation will be like, it will be very difficult for you to implement such a pattern. So if you know what the UML representation of that pattern will be, it will be very good. So over here we have a product, let's say a product, a vehicle, and then other product that will be implementing this interface, right? And then we have a factory over here that will be depending on whatever argument to pass to it on runtime. We will decide on which of the objects to instantiate. So that way you don't have to do a lot of if else, check if the product is product A, then instantiate this, if it is this, instantiate that. All what it does, you just pass whatever object you want to create to this factory, and then it automatically finds the object to create for you on runtime. So let me have how good demonstration. Okay. So this is a code representation of the design pattern. Can you see? This is a code representation. So this is an interface, a vehicle that have some methods that will be implemented by the classes that implement it. And then we have the truck which will implement the vehicle, a car which also implements it. And then we have the garage that at this point in time is serving as our factory, right? So this is a bad way of writing code, right? So at this point you realize that over here I'm checking to see if it is a truck, then I create a truck object. Over here I check if it is a car, and then so assuming you have a lot of classes that are implementing that vehicle, you do a lot of if else, and anytime a new vehicle is added, you come and change this code and add a new if else, which probably is not maintainable. So I'll show you how to do it with the design pattern. So with the factory pattern, at this point in time, this is the over here. So this is the factory, right? This is the factory. Over here, all what it takes is to check, to take the type of vehicle you want to instantiate and check to see if that file exists or if there's a class of that sort. And then it returns that particular class. It instantiates that object and then it goes away. So if you have thousands of other vehicles coming out, all you have to do is create that class and then make sure it implements the vehicle interface, and we are off. So anytime, so this code can withstand change. Whatever changes you don't have to come back to change this code. So let's move on to behavioral patterns. So behavioral patterns only check for how objects communicate with each other, right? They make sure that the way objects communicate with each other is very efficient, and a change in one object wouldn't affect the other, right? So that they move smoothly. And these are the various types of behavioral patterns. There are, amongst others, strategy, observer, state. But I'll touch on the strategy pattern briefly. It defines a set of algorithms, right, and make sure that those strategies can be implemented. It's just like having a business. You have a strategy for going to a particular market, and as a business, you have various strategies. You can either use strategy A or strategy B without necessarily changing your code base. So this is a UML representation of the strategy pattern, right? This is the strategy, and these are the various strategies that you want to use. Implementing the strategy class, right? So this, the context, all you have to pass is pass the strategy that you want to use, and then it goes, and then that's the job for you. So let me show the code. So the strategy pattern. The strategy pattern. We have a file and an abstract class animal where I create dogs and birds from them, right? And you know that birds fly and dogs don't fly. They probably walk or run, right? And if you are creating this class, you might probably want to give them a motion ability, which is birds will fly and dogs will walk. But if so, this is the wrong way of doing it, right? Putting the motion ability of each animal in the superclass for the subclasses to either inherit from it or override it. You might think that, okay, if you put it over here, the dog and bird class will probably override this method and do their own thing. So the dog is overriding that movement, saying I'm walking, and then the bird says what? I am flying. But the problem with this is, anytime this motion changes, you have to come back to this code and then change whatever movement there is. This it might seem simple, but sometimes the strategies involves a lot of algorithms that you might not want to be changing frequently. So the best way to do is go with the strategy pattern. where we have a motion interface, right? A motion interface. And then the various motions there are, whether flies, walks. Yeah, for now we have flies and walks. And all these motions implement the motion interface. So that when you are creating a dog, you are creating a new dog and you are giving it a new motion ability. So the dog is flying. And if you want to change if some few years to come and then the dogs want to swim or crawl, all you have to do is create a new class implementing the motions interface, and then you pass it as an argument. So if dogs walk, all you have to change is what, right? And right there, you've changed the ability, you've given it a different strategy to either walk or fly. Let's move on to the structural patterns. These are patterns that identify various ways to realize the relationship between entities. And I'll talk more about these are the various structural design patterns. The adapter, bridge, creator, composite, facade. And I'll touch more on the creator pattern. So let's assume that we are building an application where we are selling wache, right? And various people buy wache. Somebody will buy only wache. Someone will buy wache with Gary and Italia. Somebody will buy wache and Italia or spaghetti, right? You probably, in good representation, you might probably want to create various classes for the various food and condiments. So you have a class for wache with Gary and Talia. You have a class for wache with Gary, and if there's kelewele, you have wache with kelewele, wache with Gary and kelewele, which might probably not say. So that in each of the classes you can compute the cost and then the description. But with the decorator pattern, what it enables you to do is you create one object and you decorate it with other objects. So you have the wache, you've created the wache, and if you want to add Gary to it, you decorate the wache with Gary, decorate it with Talia and kelewele, fish with whatever. So doing this with the pattern, we have an interface which is called meal, right? Which all the meals, whether wache or the condiments, will implement from. And it has an abstract function which has to be implemented in all the functions that will extend from this function, right? So in this point, the wache will extend the meal, and we have another abstract class which is the condiments, which is the Gary and all those kelewele stuff that you add to your main meal, which will also implement the meal class, so that it will make it easy for them to be able to develop them. So this is how it looks like when you're implementing. So all you have to do is create a new wache class, right? And then or instantiate a new wache object, and then you decorate the wache with a Gary object, and you decorate it with a Talia object. And you can, and in each of these classes, so in the Gary, in the condiment class, they have an instance or a reference to the meal that they are decorating, right? So in computing the cost, we can easily get the cost of the meal over here, and then we add the cost of the condiments to it, so that it will make it easier for you to compute the cost. And same for the description. You always have a reference to the meal that they are decorating, so that you don't have to compute all the various wache, add Gary, all in one place.
Can you go back to the index of page? The page about this one. This one. What do you mean by watching equals to new Gary to that is watching?
Yeah.
When you extend the class, and I maybe instantiates it right.
Yeah.
Won't I get all the methods in which it has been extended in the parent class?
When if you instantiate
So
this,
like I can just do watch equals to watch equals to new watch. So I get the new
and at this point, Gary has a reference to whatever meal you pass to it.
So what's Gary here? The Gary is a complement.
Yes,
It extends the complement.
Yeah, extends the complement interface, not the meal interface. Right. So this is a UML representation of the decorator pattern. You have this is the decorator, an interface where all the other condiments will extend from. So all the curry, spaghetti, what are the Indomie, all from here. And over here will be that of the main meal, be it wachi, rice, jollof, so that you can take one of them and then you decorate it with all the other classes under the decorator. I just did a demo.
Alright, so we have time for only 2 questions. So questions on design patterns, anyone?
But if you have any further question that you don't have time for,
Which pattern do you suggest?
it depends on the problem you face, right? One pattern cannot solve all the problems, right? If you have a problem of just having to instantiate one object so that it has effect in throughout the application, right? And you want to instantiate it just once, then you have to use a singleton pattern, right? And if you want to, we have pattern that helps you to make sure that to manage the way you connect with external services, like the various APIs that you talk about. You have so that if you don't do it that way, you might probably have to be changing the code base each and every day. So it's mostly dependent on the problem you are facing. And these patterns solve specific problems.
Right, last question.
It's not really a question. I think as patterns they are good things sometimes too, but people have bad sides to up. There's always this back and forth debate about some patterns. Some of them don't like help in unit testing. If you want to unit test your application, like Singleton, people usually argue against it that maybe some testing endorsements it doesn't really, and the abstraction people don't get it something. So I think it will depend on the advantage of something.
As I mentioned earlier on in the beginning, the pattern it has the consequences, right? It has the name, the problem, the solution, the consequences. The other trade-offs that you might make of the way to do that. And those were the trade-offs that I highlighted.
Alright,
Right.
let's give it a go.